Hey everybody, today I'll show you how to use the I2C communication between an EV3 and an Arduino with RobotC. While communication works both ways, sending data from the EV3 to the Arduino has a nasty catch due to a bug, so stay until the end to see how to avoid this bug. In this video I'll show you how to build and program this setup from scratch. You can also find the code in the description. First we have to connect the EV3 to the Arduino. To do this, I cut a standard EV3 cable and soldered some extension to the wires. As you can see, there are 6 wires, but for I2C we only need 3. The red one is ground, which goes to the Arduino's ground pin. The yellow one is SCL and the blue one is SDA. You might have read online that you need pull-up resistors to connect these, but since the EV3 has internal pull-ups, you actually don't need them for short cables. Here we will plug the cable into sensor port 1, but every other sensor port will also work. The red cable plugs into ground. The blue one goes into SDA. And the yellow one goes into SCL. Now we have to connect the potentiometer. Connect the 2 outer pins to 5 volt and ground. And the middle one goes into analog pin 0. To start, let's configure the sensor pin. We'll name it Arduino and set the sensor type to I2C custom. Then we need a while loop that runs forever. Inside the loop, we define an input buffer with a size of 2 bytes and set it to 0. We also need a buffer for our outgoing message. This buffer needs to be at least 2 bytes. If you want to send additional data later, you need to increase this size. The first byte of the outgoing buffer contains the message size. Even though we aren't sending any payload data yet, the Arduino's address itself counts as data. So we set the size to 1. The second byte holds the address. In our case, we set it to 3. As you might know, I2C addresses need to be left shifted, so don't forget that. Now we can send the message using the send I2C message function. This first argument is the sensor port. We use the Arduino alias we configured earlier. The second argument is our outgoing buffer, and the third argument is the amount of bytes we want to read back from the Arduino. Once the message is sent, we have to wait for the communication to finish. We do this by checking the status of the sensor port. As long as the status is pending, the communication is still ongoing. Once it's done, we can read the answer using read I2C reply. This function needs the sensor port, a buffer to copy the reply into, and a number of bytes we want to copy. At this point, we should check if the communication failed. If that's the case, I'll just make the EV3 play a sound, but you can implement your own error handling here. If it didn't fail, we need to assemble the value. Since I2C only supports bytewise communication, and our potentiometer value consists of 2 bytes, we have to left shift the high byte and then combine it with the low byte. Finally, we just need to clear the display and show the value. Let's also add a short sleep command here to give the Arduino some time to measure the potentiometer. Now let's move on to the Arduino code. We'll read the potentiometer value and send it to the EV3. To start, we need to include the wire library. This should already be installed if you use the Arduino IDE. Next, we define the slave address as 3 and set the potentiometer pin to A0. We also need a volatile integer to hold the potentiometer value. This integer must be volatile because we'll be accessing it inside an interrupt function. In the setup, we first disable interrupts. Then we start the I2C communication with our defined address. Crucially, we need to register an onRequest interrupt method. After that, I like to wait a short moment to let the system settle, and then we enable the interrupts again. In the loop, we simply read the potentiometer value and save it into our variable. Then we add a delay of 100 milliseconds. Now for the most important part, implementing the request event method. This method gets called automatically every time the EV3 requests data from the Arduino. First, let's copy the global value into a local integer variable. This prevents race conditions where the value might change while we are reading it. Then we send the value to the EV3. Since I2C sends data byte by byte, we have to split our integer using the high byte and low byte functions. Note that this specific method works for 16-bit integers. If you use larger numbers or floating point values, you would need to adjust the code to account for that. As you can see, the EV3 shows the value on its screen. Now it's time to implement the buttons controlling the LED. To turn the LED on, the Arduino doesn't need to send any data back, so we could technically set the reply length to 0. But here is where I ran into a problem. If it's set to 0, the EV3 won't send a stop condition, which leads to some unexpected behavior on the Arduino. So even if you don't need any data from the Arduino, you have to use a reply length of at least 1. Luckily, you don't need to worry about this when writing your Arduino code. Because of the way I2C is implemented, the Arduino will always respond with the requested amount of data, regardless of what you defined in the request interrupt. We also don't need to read this incoming dummy data, because the buffer is cleared every time a new conversation starts. First, we need to check if the button has been pressed. If it is, we need to define our message. This time it needs to be a bit bigger, because we have to send a value to indicate which button was pressed. So we set our message size to 2. The address of the Arduino stays the same. But we'll set the second byte of the message to 1, indicating that the LED should turn on. Now we can send the message to the Arduino and request 1 byte from it. If you want, you could use the same method we used earlier to wait and check for errors, but I'll skip that part here. Instead, I'm just going to do a little bit of delay. For turning the LED off, I'll just copy the code, replace the button with the button down, and set the second byte of the message to 0. And that's it. On the Arduino side, the code is pretty simple. First, we have to define the pin for the LED. I'm going to use the built-in LED. In the setup function, we need to add a receive event interrupt method to our wire instance. This gets called automatically whenever the EV3 sends data. Keep in mind that the onRequest interrupt we set up earlier will get called directly after this receive event. Of course, we also need to configure the LED pin as an output. Now we can write the receive event method itself. It takes 1 argument, which is the number of bytes received from the EV3. Inside the method, as long as there are new bytes available, we are going to read them one by one. If the byte is a 0, we turn the LED off. If the byte is a 1, we turn the LED on. And that's it. Keep in mind that the code inside these 2 interrupt methods needs to be very fast. The code we have here is perfectly fine, but if you need to run more complex tasks, I highly suggest preparing the data in the main loop and just copying it during the interrupt. Also, never use serial print inside an interrupt. That will definitely cause trouble. Now we also can control the LED on the Arduino. I hope this video helped you. If it did, please leave a like and subscribe. If you have any questions, just write a comment. So, see you at the next one.